So let's get some ideas. So I didn't quite see, except for only one person's paper in the classroom. I'll share with you what that person did. So one person saw that Corey's sandwich was split into thirds, and one person saw that Ben's was split into fourths. So this is what that one person in the classroom did. They split their sandwich for Ben into thirds as well. And then I saw them split Corey's sandwich into fourths. Raise your hand silently if you also did that. All right, so some of the people who did that, I saw your paper, so I took it from that. Awesome. Put your hands down. So now, looking here, why is it important to have these same size pieces if we're going to compare them? Why is that important to make them the same size before we compare them? Think about it. Why can't we just do the 1/4 and 1/3 and compare? Why should we do same size pieces? See Gianni thinking about it. Think about how many pieces there are now in each sandwich. See some hands up, some ideas. All right, Darlene, yes. Yeah, it's easier to compare them because now they're the same size. Yes, Malia? 3/12. All right, 3/12. So we can put that down there, 3/12. Now for Corey, how much of the sandwich does Corey now have once we cut it up? All right, Elijah? All right, 4/12. Now my question is, how much more did Corey get? That's what we're trying to answer. How much more of the sandwich did he get than Ben? See 2 hands up. See 3 hands up. Look at these fractions. We made new fractions. So how much more did Corey get? See more hands up. Still need to see about 2 more hands up. Look at these fractions. How much more? All right, let's go with Lanier. All right, 1/12. So Corey got more, and that difference then was 1/12. So we're going to put that in our answer. So let's go ahead and write our sentence out. So Corey had, raise your hand, 1/12 more of a sandwich. And when that's written on your paper, sit in slant. Yes, what's your question?
How could Corey get more and look at the denominator then?
Yeah, so these fractions were different. 1/4 and 1/3. Are those the same fractions? No. But between 1/4 and 1/3, 1/3 we found out is more than 1/4 of a sandwich.
So if I have 1/5.
Wait, sit correctly in your chair.
If I have 1/5 and 1/4,
Yeah. Thank you. All right, so we're going to go ahead and move on. So looking at this on your guys' papers, we notice that we made the denominators the same. So I need someone to read this right here because it's something very important. We compared 2 different fractions. So now let's read this statement right here. All right, Tamaje, read it clear.
In order to compare fractions with different denominators, we usually rewrite fractions to have the same one.
Great, we write them to have the same denominator so we can compare them. All right, let's go ahead and move on now. So I'm going to show you guys another way to find this denominator. So it can be kind of hard to draw a find this common denominator. We have 1/4 and we have 1/3. As we notice with the sandwiches, we split 1/4 into 3 more sections. We cut it up. So what we're going to do is we're going to first find the first common multiple between them, and then we're going to go back to how we cut the sandwiches up. So I have the multiples of 4 and the multiples of 3. Remember, multiples are where we skip count by those numbers. So can someone skip count for me number 4 or 4? 4 is the first one. What's the next one, Richie?
8.
Great, let's go to 3. After 3, what's the next one going to be, Layla? 6. All right, now let's go back to 4. After 8, the next one's going to be Darlene. What's the next one going to be? Great. All right, after 6, the next one's going to be Nyla. Yes, after 6. 9, great. So let's go one more on the 3, Gianni.
12.
All right, 12. So we have 12, that's the least common multiple. It's the first number they both have in common that they can multiply into. So I'm going to go ahead and do this. 1/4, as we saw earlier, if we cut it into 3 more sections, we get 12 for that denominator. There's 12 total pieces in those sandwiches. And then we had 3 of those 12 pieces. So I found my common denominator, which was 12. I knew I had to multiply by 3. What I do to one part of this fraction, I also have to do it to the other part to make it equal. So can someone tell us for 1/3, what am I going to be multiplying that by to get that denominator that we found? Ashton?
4.
4, good job. So, times it by 4, times them by 4, we get 4/12. This is just like our ratio tables we've been doing this week. The only difference is we can just put them right in the fractions and multiply over and get those. All right, now it's fractions, 1/4 and 2/6. Remember, Miss Curtis, what we did together, we had 4. And then now we don't have 3 anymore. We have the denominator of what? 6. So go ahead and list out those multiples of 4 and 6 and find the least common denominator. It's that first number they both have in common. DeAndre knows. Yeah, so write it down on your paper so you can show me. Ooh. Tell us what was the first multiple. What's that least common denominator? So let's see the popsicle stick. Which person? 1 second, Joanna. All right, seat number 22. All right, who is seat number 22? All right, Nyla, what was it? 12. Do we agree, disagree?
Agree.
All right, so we have 4, 8, 12. We had 6, 12. It's going to be 12. Awesome. Now, let's go ahead and do the next one. The next 2 fractions, we have 3/4 and 7/12. So, we have 4 again, and we have 12 now. Go ahead and find that least common denominator. Yes, here we go. I'm gonna call on a popsicle stick, so y'all should be solving it. I see Jason listing out his numbers to find that least common denominator. I see Kasai doing it as well. So you did 4, 8, 12. What was the first number for the 12?
12.
Yeah, so what's that common denominator?
12, okay.
All right, let's bring it back in 5, 4, 3, 2, 1, 0. All right, let's see which seat number. Seat number 9. So sitting in seat number 9, Malia.
Eyes on you.
All right, we're gonna listen to Malia tell us what that common denominator was. All right, she got 12. So we had 4, 8, 12, 12. Now, we're gonna go one step further. We're gonna make equivalent fractions now. So I have 3. I have 3/4, and we're trying to get to that denominator of 12. So what am I multiplying that 4 by to get to that 12, Charles?
3.
Great. So our new numerator is going to be what, Jason Allen? Devin, we're on this right now, and so this should be in your math notebook. So keep writing. Stay with us. All right, now 7/12. What do I have to multiply 12 by to get to 12? DeAndre? 1. And so then class, 7 times 1 is?
1.
7 times 1 is?
7.
Okay. All right, we have our new fractions, 9/12 and 7/12. Which one's greater?
Oh.
Jason Miguel? 9/12 or 3/4 would be greater. All right. So, now can I have someone read this question? Because we did a couple of problems, so let's summarize what we've been doing these past couple of problems. All right. Vianney, please read it.
Remember when comparing two fractions with different denominators? What should we do?
Great. When we're comparing fractions at different denominators, what should we do? When they have different denominators and we're comparing them, what should we do? I see this whole table. They're thinking about what we should do with that table. Good job. All right, Elijah, help us out. Find that common denominator. Awesome. All right. All right, Cal State LA, 1, 2, 3, eyes on me.
1, 2, eyes on you.
Thank you, Charles, for your eyes. Thank you, Tamaje, for yours. Thank you, Malia, for yours. Vianney, make sure you give me your eyes right now. All right, thank you, Jason, for your eyes. Great, now I have everyone's eyes. So this is very important. This is a big common mistake that 5th graders, 6th graders, 7th graders make. So you're laughing now, but we want to make sure we don't make this mistake at all. Devin, give me your eyes right now. Devin, this is the second time I have to tell you to give me your eyes, so sit straight like a scholar. And I'm up here. All right, so we have 2 terms. We have the least common multiple, Tamaje. And so that is where we use whole numbers. We find the whole number 4, the whole number 3, and we find that first number, Kasai, that they have in common. So like you guys have been doing, you've been listing out your multiples, and you guys found out that the least common multiple of 4 and 3 would be 12. But the least common denominators are fractions only. So I would take this multiple of 4 and 3, I just make it a denominator. That's it. So it would just be over 12 over 12. That's all we do. Least common multiples, those whole numbers 4 and 3, we find it, and then you just make them into the denominator. That's it. But those 2 terms, people don't know the difference between them. People get them confused, but I'm telling you guys now so you guys will know the difference between them. So can someone tell me again, least common multiple, they're dealing with whole numbers or are they dealing with fractions? Well, the least common multiple, what is that one pertaining to? Richie?
12.
That it is 12, but when we look at least common multiple, are we examining the whole fraction or just that whole number on the bottom?
When we do least common multiple, are we doing the whole number or fraction?
Oh, whole number.
Yes, least common multiple. Any whole number in the whole wide world, you can find that least common multiple. Now, least common denominator, what is that pertaining to? All right, Charles? The fraction. All right, that's it. So we're going to move on. This will be the last part of class before we're going to transition to our exit ticket. So let's go ahead and make sure we know how to do it. Go ahead and turn to this page in your packet in 5 seconds, 4 seconds, 3, turn there in 2, 1, get there in your packet in 0. We're going to turn around. We're going to make sure that we're focusing, okay? Elijah. So you can put this away and you can put this away.
Wait, this too?
No, just the book and this way. Thank you. Awesome. You ready to learn? Hold on. All right. 3, 2, 1, 0. Thank you, scholars, for even though I said 5 seconds, I still have to wait a little bit, so thank you for those who are showing integrity. All right. This will help us find equivalent fractions. You will see a problem similar to this on your exit ticket in 1 moment, so make sure we know how to do it now. So what we're going to do is we're going to cut up these different squares. I'm going to model the first one for you. We're going to do the second one together, and the last one you'll do on your own. So this one, A, I have 1/6 and 1/2. So I'm going to make sure I cut them into equal size squares. So I'm going to go ahead and cut this one into halves. And notice how Miss Curtis saw that this square had lines that were going horizontal. So it would make no sense if I did another horizontal line, I wouldn't be able to cut it in half properly. So I did that vertical line to make sure I cut it in half. I could see those pieces. Hold on a second, still modeling. And then I have 1/2. I need to cut it into those 6 sections that this other one was cut into. So these are horizontal, so I'm going to go up and down vertical again. I cut it in half. And then to make it into 6, I cut this side into thirds. And this side into thirds. So I have a total of 1, 2, 3, 4, 5 of these lines to make one section. 2, 3, 4, 5, 6 sections now. Now I can make my new equivalent fraction. I look here, and I have a total of 6 and another 6. That's a total of 12 pieces. Out of those 12 pieces, I only have 2 of them. I'll show up in one moment for you. And on this other one, we have a total of 12 pieces. But on this one, I only have 6 of them shaded. So we're going to try B together. I'm going to give you guys time to start B on your own, then we'll come back in about a minute. So number B, start dividing each side of those fractions into those equal pieces. Pencil? Alright, sorry, DeAndre's in stand, he's ready. Olivia's in great stand, she's ready. Survey, good job. That's really good. Really, you guys on one spot is what we do that. Someone else. I'm going to go ahead and take away those dollars from students who have been distracting us. They're not being engaged. I'll say it one more time. 1, 2, 3, eyes on you.
1, 2, eyes on you.
Alright, that 100%. So this last part, did you guys just see in your exit ticket? There's some at least common multiples. We just have to find the least common multiple of 2 whole numbers. So the first one is 3 and 5. So let's list the multiples of 3 and 5. So let's count as a class. The next one after 3 is what? 6. Next one after 5 is what? 2. After 6 is what? 9. After 9 is what? 12. Alright, let's keep going this one. After 10 is what? 15. After this is what? 15. There we go. It'd be 15 is at least common multiple. Now this one, 4 and 5, do it on your own, and once you do it, I'm going to give you the OK to start your exit ticket. So you must do that last one of B. And only when I give you a check mark can you move on to your exit ticket. And then we have our daily practice and exit ticket. So right now we're going to do our problem screen for number corner. So the only thing that you'll need to bring is your math notebook and your pencil. And so remember, it's been a while since you've been in the math discussion area. So can someone remind the class what should our voice level be as we're moving from our seat to the math discussion area? Joanna? Not quiet. Jason? Rest. That's silent. All right, now how should we? All right, what we need to do is we need to make sure our packets get back into our binders behind the red tab. Stack your binders, clean everything up. 1 minute, go. People, get $100. Oh, 100. 1 minute only. I'm Janelle Curtis and I teach 5th grade mathematics. Yes, there's 2 main objectives. The first one is to find the least common multiple for 2 whole numbers and use that to apply to the least common denominator for 2 fractions. And the other objective is really to either use the least common denominator or even any common denominator to make 2 new equivalent fractions and compare them to each other. So this lesson is the last module in the unit, and so for the past 3 weeks students have already been adding and subtracting fractions. So they already had a lot of experience with finding common denominators and even simplifying fractions and thinking about how they can find the least common denominator. So when this lesson came up, a lot of the students had already known and heard these terms before, and so the idea of least common denominator was really already set and implanted in their minds. I usually plan depending on the classroom itself. All of my classes have various levels of rigor and just different student levels, and so I knew the class that I had was really so far has shown a lot of lower level students. There's a small group of students who are high achieving, but the rest of them are struggling. And so I keep that in my mind when I do my engagement. So I go ahead and put a lot of turn-in talks for them to talk to their partners. I give them think time to actually look at the question and think about the question before they answer it, and time to even solve it out for that level of engagement to increase. But I also do this pre-planned in my lesson. So I think about what the objective is, and I think about what questions are the most important that they should be getting out. But I always think about that class first, depending on their levels. Yes. So my struggles that I have are more about what's to focus on for each class. I've noticed throughout teaching it, some classes will understand one concept better and the other concept they'll have more struggles with. So when I go into each lesson plan, I try to think about this particular class, what will their strengths be and what will their weaknesses be? And so when I set up the lesson, for some classes I may do these problems and focus on this and go deeper into it, but other classes I might skip those problems and do other problems instead for them. So it's always been a struggle of matching the class itself and figuring out how to plan out my lesson and execute it for them. So for my classroom, next we're going to start going into decimal numbers and looking at conversions. And so we're going to be transitioning from adding and subtracting fractions into decimal numbers. And so we'll see how that applies to them. Yes. So for me, I do equitable calling, but I let students know beforehand for it so they're not caught on the spot and we're not wasting time. And so when I do equitable calling, I let students solve out the problem. So I walk the room to see who's getting it and who's not. So that's also my progress monitoring. And then also when I ask key questions, I also walk the room to see which students are really understanding it and what strategies they use to solve it. And then I look at other students and see what they're struggling at, where they're stuck at. And so for teachers who are struggling with how to increase that engagement, if you want students to answer more and participate more, let them know beforehand. You're going to let them know that question you're going to call on them, give them time to solve it, and then see those hands fly up. And then for progress monitoring, it's okay to walk the room and take that time individually to answer kids' questions in the middle of a lesson. You don't have to do it all during the daily practice. It can be throughout your teaching part of the lesson. Yeah.